Good evening, everyone. My name is Gagan Kaur. Right now, I am teaching Operation Research in final year, and my today topic is transportation model. It is in second unit, and it is related to assignment model. Like I told in assignment model that there is one source and one destination, but in this case, uh, transportation in transportation method, we have one source, one destination, but number of we have to mainly cater with the minimizing of the shipping cost. Like a transportation problem is a classic operation research problem where the objective is to determine the schedule of transportation good from source to destination, as well as keeping in mind that we have to minimize the cost. A typical transportation problem has following elements like sources. There may be number of sources, like we are transporting milk to different destinations. Then we have many sources and many destinations, and weighted edges showing the cost of transportation. This is a simple example in a graphical view. Here we can see that there is factory 1 and factory 2. It is supplying, it has a supply of 4, 6 and 10, which it is supplying to the demand of warehouse 1, 2 and 3. Similarly, in case of factory 2, they are supplying 2, 7 and 8 to the first, second and third warehouse. Total demand of different warehouses is given there. Before continuing, I would like to elaborate all this problem into with the help of an example. Okay, let's take an example. Like, for example, there are 3 milk plants, plant 1, plant 2 and plant 3. There are 3 milk plants and they are providing milk to different destinations, distribution center, like 1, 2, 3, 4. There are 4 distribution center, D1, D2, D3 and D4. The supply given by the plant 1 is 6 million liter of milk. The supply given by plant 2 is 1 million liter of milk, and the supply given by the plant 3 is 10 million liter. The demand of different distribution centers are 7 for distribution center 1, 5 for distribution center 2, 3 and 2. These cells are the cost associated while transporting milk from plant 1 to distribution center 1. Like, if we want to distribute our milk from plant 1 to distribution center 1, then the cost incurred is 2. All the costs are in 100. 200 rupees is the cost of transportation. Similarly, for other, it is given for from plant 1 to distribution center 2 is 300, for 3 is 1100 and 4 is 700. Similarly, all the cases prevail like this: 1, 0, 6 and 1, and the last one is 5, 8, 15 and 9. So this is a typical case of a transportation model. Here we can see all the cost associated for transporting milk to different distribution center. This is known as the transportation model. Now, there are various methods which can be used to solve this particular set of metrics. Number 1 is northwest corner method. Number 2 is row minima method. Number 3 is column minima method. Number 4 is least cost method. And last one, which is the most important, is Vogel approximation method. VAM method. Basically, these all methods are hit and trial method. Apart from Vogel approximation method, Vogel approximation has a logic behind that I will tell you while solving this problem. Rest of these 4 are hit and trial method. So, continuing with this, I will first explain what is northwest corner method. Like in north corner vested, it states that this is the, for example, this cell 2 is the northwest corner of the matrix, like this. This is the northwest corner of the matrix. So, we will start from here. Here, we can see that plant 1 can give 6 million liter of milk, but the requirement over here in distribution center 1 is 7. So, it can give only 6 million liter, that I can write over here. So, the supply is completed. So, plant 1 cannot give any further you can say object to any of the distribution center. So, here only 1 is left. 1. The requirement is still not fulfilled for distribution center 1. So, we will cross out this line so that we may not confuse with any other line. For example, now in second northwest corner, now it is 1. So, 1 is supply and 1 is your demand. So, we can give 1 over here, this is 0. And this also become 0. So, we will cross out, similarly we will cross out this and this also. Now, the next northwest corner is 8. So, here we can see the demand is 5, supply is 10, it comes out to be 0, we will cross out this. Now, in 9 there is 2, here there is 3. So, in this way, whole demand and supply is balanced. One thing I want to add, that we cannot process this whole problem until and unless the supply is equal to demand. It should always be equal to demand. In any case, it is not equal. For example, here you can see 6 plus 1 plus 10 is equal to 17 and the sum of demand is also 17. But in any case, when it happens that they are not equal, for example, it comes out the supply is 70 and demand is 15. So, wherever the case is like that, if the demand is 15, that means we have to add one column containing 0 cost, like I said earlier in the assignment model, and we have to assign 2 demand to 0 column. In this way, we can balance and then we can process this whole matrix. Now, what we have to do, we have to find out the cost. The cost over here is, we have to multiply this 2, that is the cost per million liter, into 6 plus 1 into 1 plus 8 into 5 plus 15 into 3 plus 9 into 2. So, here our sum comes out to be, since it is in 100, so we will multiply it by 100. So, our sum comes out to be, that is equal to near about 11600 rupees 11600. This is the northwest corner method. Now our next method is row minima method. Row minima method and column minima method are more or like same. I will just explain one, that is row minima method. Column minima method you can solve yourself. It is not a big issue with that. Now I will rewrite this equation. 4 distribution centers and 3 plants. That is 2, 3, 11, 7, 1, 0, 6, 1, 5, 8, 15, 9. Demand is 7, 5, 3, 2, 6, 1, 10. Okay. So now I will tell you the second method, hit and trial method, for which is used for finding out the solution for the transportation model. That is row minima method. Now we have to take, for example, we have to take the first row. We have to find out which is the minimum cost in the first row. Here it is 2. So this is the minimum number in the first row. Here similarly 6 is the supply and 7 is the demand. We will allocate 6 over here. This comes out to be 0. This is 1. Similarly, this whole equation is solved. So we will cancel out this row, since there is no more allocation can be done over here. Now second one, which is the minimum number over here, it is 0. So we will allocate 1. 1 is the supply and 5 is the demand in this whole cell. So this comes out to be 0 and there is 4. So we will cancel this whole equation, sorry, whole row. Now we will come to the third row. Here the minimum number is 5. Here 10 is the supply and 1 is the demand. We will allocate 1 to 5. Here it comes out to be 9 and here it comes 0. So we will cancel this column. Now among these three, which is the minimum number? 8. Yes, the requirement is 4 over here, like we have seen. It comes out to be 0. Here comes out to be 5. Okay, so this also becomes, we will cross this line. Now between 15 and 19, 9, which is the minimum number? 9. So here 2 is requirement, it is 3, and similarly 3 over here. These are all becoming 0. So in this way we solve out this matrix with the help of row minima method. So now similar we will do here 2 into 6 plus 0 into 1 plus 5 into 1 plus 8 into 4 plus 15 into 3 plus 9 into 2. The answer will come out to be around, you can note here, the answer is 11600. Here it will come around rupees 11200. So you can see your cost is reduced and it is just hit and try. It is not definite that this is better or that is better. So row minima method, we have a this cost is obtained with the help of row minima. Now I will come to the third method, that is column minima is same. Just you have to pick out the minimum number, minimum cost in your matrix. For example, here we can see 2, 1, 3. 1 is the minimum number. We will allocate first over here. So this is the column minima method. Similar process like that in row minima method, it is similar in column minima method. Now I will go to the third method, that is least cost method. I will take the similar example of least cost method. In this example, since I am taking similar metrics, because for finding out what is the difference between all these methods, we have to have a similar example. That's why I am taking the similar method. Now, I will rewrite this equation, this matrix, sorry. Two, 3, 11, 7, 1061, 58, 15, 9. Similarly, plant 1, plant 2, plant 3, and distribution center 1, distribution center 2, 3, and distribution center 4. And similar, supply is 1610 and demand is 7532. Sorry. Now, least cost method is takes into account the we have in row minima and column minima. We have taken the least number in row or in column, but in this least cost method, we will take the whole matrix. The number which is minimum in the whole matrix would be taken first. Like in this matrix, 0 is given, we will take 0 first. So here 0 is the minimum element over here. So you can see the supply here is 1 and the demand is 5, but since supply is less, so we can only give 1 to 0. So here this is over. Now we will find out the minimum between these elements. So 2 is the minimum. So here supply is 6 and demand is your 7. So 1 still demand is left. So whole of this will be cancelled, and then we have 5, 8, 15, 9. Here the minimum number is 5, where 1 is required over here. Okay, so it comes out to be 9. We will cancel this column. Now minimum number is 8, 4 is required. So here we will 5 is left. So we will cancel out this column. Now for 9 is the smallest. So 2 will be allocated. Similarly, 3 will be allocated. So this is process. So we have now, according to least cost method, we have solved this matrix. Now we will find out the cost associated with the least cost method. 2 into 6 plus 1 into 0 plus 5 into 1 plus 8 into 4 plus 15 into 3 plus 9 into 2 into 100. So the total cost with this least cost method comes out to be around 11200. Similar, rupees 11200. So these are only hit and trial methods. We don't know which will give the best one solution. Okay. Now the method, that is Vogel approximation method, which is widely used because it is the best among all these 4 methods. It gives us the minimum cost, but still we have to validate that minimum cost. We have to find out whether this minimum cost is okay or not. So first of all, I will tell you how to solve the Vogel approximation method. If you are doing transportation, then you definitely have to solve transportation with the help of VAM method, because it gives the best result. Similar example I will take. As I told you, I am taking the same example again and again so that there is a comparison between these all 5 methods. Now, 2, 3, 11, 7, 1061, 5, 8, 15, 9. 5, 8, 15, 9. Rest 6, 1, 10 and 7, 5, 3, 2. Plant 1, plant 2, plant 3 and distribution 1, 2, 3 and 4. Now, first of all, I will tell you what is the basic logic behind Vogel approximation. In Vogel approximation method, we are actually minimizing our regret. What is regret over here? For example, I am choosing the second smallest number in a column on a row. That means I haven't chosen the first one, so there is some loss between first and second one. So that's why we have to take care where the loss is maximum. We have to designate that column or row first. For example, I will take this. Like in this first row, 2 and 3 are the first and the second minimum numbers. If by any mistake I choose 3, then the loss will be around 3 minus 2, 1. Similarly, over here 1 minus 0, 1. Similarly, 5 and 8 are the minimum numbers. It is 3. Now we will come to column. Here 1 and 2 are the minimum number. 3 and 0 minimum number. 11, 6, 5. 7 and 1, 6. Now see here, 6 is the maximum regret. That means if we will choose 7 instead of 1, then the cost will increase around 600 rupees. So we have to take care over here that we will choose 1 only. That's why this column will be selected first. Now in this column the minimum number is 1, plant is giving 1 and the demand is 2, so 1 is left over here. Here it is 0, so this will be eliminated. Okay, again we will do this procedure. Now similarly, 2 minus 3, we will not take this row because since it is cancelled, it is 3. Now we will take column. 2 minus 5, 3, 5, 4 and 2. Now the maximum regret over here is 5. So what we will do? We will choose this column. Okay. If we will choose this column, we can minimize our regret by 500 rupees. So here the minimum number is 3. So we will allocate first of all 3. The demand is, here is 5. So 1 is left. So we will first remove this. Now we will again find out the regret, that is, this is 5, this is 4, now this is 3, 4 and 2. The maximum regret here is 5. So choose this, and what is the minimum number here? That is 2. So we will, and here the plant supply is only 1, so we can only give it 1. So 0. So this is also cancelled and this is 1. Now since all the rows have been cut, so we have only 3 numbers left, 5, 15 and 9. We will allocate the remaining resources to these cells. Now the minimum number is 5. Here the demand is what? Demand is 6. 0. Here comes out to be 4. So 9 is minimum number 1. Here comes out to be 3. This is 0. This is 0. This is 3. So in this way, whole VAM method is solved. Now we will find out what is the cost. So cost is 2 into 1 plus 3 into 5 plus 1 into 1 plus 5 into 6 plus 15 into 3 plus 9 into 1 into 100. So it comes around 10200 rupees. Now look at the cost of each and every method. It is 10,200, it is 11,200, it is 11,200 and this one is 11,600. So as I told you, this method give us the minimum cost. So while performing this, while finding out the solution for transportation, you have to choose VAM method. Until unless it is given, you have to solve it with northwest corner method, then you have to follow that. If it is given solve the transportation method, you just have to follow VAM method only, because it gives us the best solution. Now it is the best solution. How to validate this? To validate this, we have another method that is known as MODI method, modified distribution method. Modified distribution method. In MODI method, what we have to do, we have to perform an optimality test first. What is optimality test? Like here, we can see that there are 4, 1, 2, how many allocations are there? Number of allocations is equal to 1, 2, 3, 4, 5, 6. 6 allocations are there. Okay. So optimality test is number of allocation is equal to m plus n minus 1. This is optimality test. M is the number of rows, n is the number of columns, minus 1. If they are equal, then we can further proceed to MODI test. If they are not equal, for example, then a degeneracy condition has been arrived. That means there is 1 less, 2 less, or 2 less allocations are there. So here we will see what will happen. Now m is 4 plus n is 3 minus 1 is 6. Number of allocation is 6 and this is 6. So optimally, according to our optimality test, we can go further. So next method is our MODI method. In modified distribution method, what we will be doing actually, we will find out whether the solution which is provided by us is up to the mark or not. For doing that, we will first of all see the allocated cells. Like here, the allocated cells are, let me draw it again. We will just fill the cells of with the cost of allocated cells. Look here, like it is 2, 3, 1, 2, 3, 1, 5, 15, 9. 5, 15 and 9. These are the costs associated with the allocated cell. Now, MODI method is also known as UV method. UV method states that like this, we will designate this rows into U1, U2 and U3 and column with V1, V2, V3 and V4. Now, what we will do, we will assign like this, like U1 plus V1 will come out to be 2, U1 plus V2 will come out to be 3, U2 plus V4 will come out to be 1, U3 plus V1 is equal to 5, U3 plus V3 is equal to 15 and U3 plus V4 is equal to 9. Okay, so whole 3, 4, 5, 6 allocations are there and we have write down this. So one of the trick to solve this is that the variable which comes more than once or twice, we will assign it 0. Now here we can see that V4 is coming out to be, or U3 is coming out more. So we will assign U3 is equal to 0. So what will happen? After assigning U3 is equal to 0, we will have V1 is equal to 5, V3 is equal to 15, V4 is equal to 9. Now put this value over here, like V1 is 5, so U1 comes out to be minus 3 and minus 3, V2 comes out to be 6 and U2 comes out to be, by putting the value of V4 is 9 minus 8. In this way, we have find out the whole variables in the equation. Anything left? I think U1, U2, U2 is left, U2, U3, U3 is left, yes, U3 is left. So, U3 is equal, U3 is given, okay, fine. So, we have whole variable available with us. Now, what we will be doing? We will use these variables and find out the value of unallocated cells. Like U1, U2, U3 is given. I will write down over here. Now, V1 is 5, V3 is 15, V4 is 9, V2 is 6. Now, U1 is minus 3, U2 is minus 8 and U3 is 0. So, we have whole variable available with us. So, what we will do? We will find out the unallocated cells like this one, these cells. So, what we will do? Minus 3 plus 15, that is 12, minus 3 plus 9, that is 6. Similarly, minus 3, minus 2 and minus 7, sorry, plus 7. Next is 5, 15 and 9. So, we have found out the unallocated cell. Now, what we will be doing? Now, we will subtract these two. After subtracting, we will find out if there is any negative element in the whole matrix. So, what was the previous element? I will write down, that is, here it was 11, 7, 106, 106, 8. Fine. So, what I will be doing? I will subtract this 11 minus, let me take another color for the pen. Okay, that will be 11 minus this, okay, 7 minus this, 1 minus this, 0 minus 2 and 6 minus 7 and here what was that? Okay, this was the unallocated cell and this was 5 minus 5, 15 minus 9 minus. So, we have the whole equation available with us. Now, what we will see? We will see whether there is any allocation left or not. Sorry, this one I think, let me do this. Actually, here was the number, I have not found it, actually it was 6. Fine. So, here it was 8 minus 6. So, now what will be the next step? I will see if there is any negative number in the whole matrix. If there is any negative number in the whole matrix, that means there the solution obtained is not optimal. So, we have to go further. We have to rearrange the allocations again. So, I can see here this is minus 1 and this also is minus 1. This is minus 1. No, sorry, this is plus 1. This is, these two are the negative equation. That means further scope of improvement is there. So, what we will be doing now, next step which comes into being is the stepping stone method. Now, what is stepping stone method? In stepping stone method, since there are two negative numbers, which the negative number which has the maximum value, that means maximum value in the sense, if it is minus 2, then that means allocation can be given to it. But there are two negative number over here. So, we will see to it whether these these allocation cannot form loop with the other. So I will tell you what we will do when we are allocating this. So for example, both of these number have come out to be negative and both are -1. So what to do now? There is a tie between them. So what we will do, we will see the number which do not make any loop in the whole equation. What is loop? That is the stepping stone method. Here you can see it is -1, it is -1. If I rotate, these are my number like this and this. Okay, I rotate from here. So they form the loop with this number. Okay, so in this, that means I can rotate this loop. In second case, here there is no loop. So the selection will be the first loop. So now what we will do? Actually what we will be doing, we will again take, I will take this equation. Now this is the loop. So the minimum allocation in this loop, I have to find out that. So what is the minimum allocation in this number, whole number? That is allocation. We have to go backward for the allocation purpose. The minimum allocation is 1. You can see this is the loop. The minimum allocation given here is 1. So what we will be doing, we will give +1 allocation here, -1 allocation here, plus alternate plus and minus, plus allocation over here and minus allocation over here. So allocation has been shifted from cell 1 to cell 3. You can see here. So what will be the number? So we have 2 here. What was the allocation? That was 2, 1 minus 1, 11, 1 allocation is there, 15, 3 minus 1 allocation is there, and 5, 6, 5. Okay. So the allocation has been changed. Now the allocation over here has been shifted to this part. Okay. So what we are doing now? Now it will comes out to be like this allocation will go there. For example, I will take this. I will rub all this. You can see here. Now the allocation will get changed. This is the whole funda behind that. Because the allocation was not correct, that's why the solution was not optimum. That's why we have to test whether the solution was optimum or not. Now here we can see that here there is no allocation, 0 is there, 0 is there, 11 got a new allocation over here. Now 15 has a less one. This counts out to be 7, and the rest of the allocation remains the same. 3, 5, 1, 1 and 9, 1. Now we will find out the cost associated with it. That comes out to be 2 into 0 plus 3 into 5 plus 11 into 1 plus 1 into 1 plus 5 into 7 plus 15 into 2 plus 9 into 1. So my cost now will reduced around 100 rupees. It will come out to be 10,100 rupees. So a single shift in allocation and we are getting more close to our minimum transportation cost. Now we have to find out whether this is the actual, it is the optimum or not. So similar process like UV method we have done. in the first iteration. Now we will have a second iteration. So similar process will be followed for the second iteration. We have to find out the u and v value for the allocated cell. Then with the help of u and v value for the we have to find out unallocated cell. So we have to subtract the original unallocated and the allocated cell. Then if there is any negative number in that matrix, then similar stepping stone method will be done, and after that the iteration will continue until you have the positive number in the matrix after UV method. So this is the whole process behind the transportation model. I hope you might have understand that. In case of any query, you can contact me or on my email ID, that is kaurgaganpreet@akgec.ac.in. Thank you very much. Jai Hind.